calculator do the number crunching for us, but we're going to do something a calculator can't do, which is interpret the meaning of our results. You don't need to write any of this yet, but let's just talk through. If little w of t gives the rate at which your net worth is changing, let's say in dollars per year, what does capital W of t, the antiderivative of w, measure? What are the units of capital W? Let's do units first. What would the units of the antiderivative be if little w is in dollars per year? Good, right? If I derive, I gain a unit of time in the denominator every time we derive. If we antiderive, I'm going to lose that unit, right? So capital W would be in dollars, and what would capital W measure? There we go. It's your net worth at any point in time. What do I mean by net worth, by the way? It's kind of like how much you're worth in dollars, okay? So they'll take your assets and subtract any debt, okay? So if you can put a number to your worth, again, in money, that's what your net worth is. So investments, assets, money in the bank, minus any debt, okay? And they'll take into account, typically, your house, expensive jewelry, etc. Okay, so little w is essentially a derivative. Do you agree with that? Because it's measuring how fast your net worth is changing. So what would w prime measure? Yeah, how quickly the rate is changing. Okay, what would the units of w prime be? Yes, dollars per year, so dollars per year squared. Okay, so what can you tell me if both w and w prime are positive? Good thing, bad thing, why? You're onto something. So remember, capital W tells me what? My net worth. So if little w is positive, that is increasing, yeah? If w prime, think about this as your second derivative essentially, right, is positive, then my rate is also increasing. So I'm essentially making money at an increasing rate. Does that make sense? I've got a concave up, I've got exponential growth essentially. Okay, so not only is my net worth increasing, it's increasing at an increasing rate. So good thing if you want a large net worth, I suppose. All right. So we're going to be doing a lot of this interpreting today. Again, I'll give you equations. We're going to make Desmos do the number crunching, but we have to do the interpreting because calculators are great for calculating. They cannot tell us what things mean in the context, right? So that's where we, as mathematicians, need to come in. All right, so let's do this. If little f of x is measured in inches per minute, what is capital F measured in, where capital F is the antiderivative? Good. And what about little f prime? So the derivative of this. Great. Okay, I would like for you to pull up Canvas and let's start part of your assignment. Let's look at question 1. If you are watching this recording, can you go ahead and pause right now, pull up the assignment, and just do question 1. It is like a fill in the table with units question. So go ahead and pause. Okay, so question 1 was just filling in the table. Now we're going to look at question 2. It says, you're pranking your friend by filling the trunk of his car with potatoes. The rate at which you put potatoes in the trunk is given by little p of t, where little p of t is measured in potatoes per minute. So I can tell little p is already a derivative function. Do you agree with that? Because we've got potatoes per minute, it's a rate. And then it says compute the integral from 0 to 5 of p of t dt, little p of 5, and little p prime of 5. So we're going to do all of that computing on Desmos. And then it says, using correct units, explain the meaning of each in the context of the problem. Okay, so before we go into computing all of this, let's do a quick review of how we explain the meaning of a rate, a derivative at a given time, because we've got really two rates going on, because p is a rate, and then we're going to take p prime as well. So remember, it goes like this: at t equals, please write this, the time in units, the, and then you're going to state original function in the context of the problem. Is, and then you're going to choose increasing or decreasing. And how do you choose? If the derivative is positive or negative, right? Respectively. At a rate of, and then absolute value of your answer with units. And remind me, why are we taking the absolute value? Beautiful. You've already stated the sign by saying the function's increasing or decreasing. So you don't want to say it's decreasing at a negative rate, because then you're actually increasing. All right, so let's make Desmos do all the computing for us. We're first going to, in line 1, put the function that was given. Just use x instead of t, please. Make sure that you are calling it something. I'm still going to call it p. So p of x equals, and then let's type that in. So 3 square root, that's just sqrt, of x, right arrow out of the x, and then sine, parentheses, 5x squared, close parentheses, plus 30. It's way up here. Not that it matters, we're not going to use the graph. Okay, and now for the next 3 lines, let's go ahead and compute the 3 things the question asked us to compute. So what was the first thing? Was it the integral from 0 to 5? And remember, integral is just int of p of t, so I'm doing p of x, don't forget your dx. The next thing it asked us to compute was p of 5. And the last thing was p prime of 5. Okay? So Desmos got all 3 of those values for us. But I want you to make sure that you can get those values on your own each time. Don't just copy them from the key. Okay? Use the key to check, not to copy. Okay, so Desmos can do all that number crunching. This is great. Desmos cannot tell us what any of this means in the context of the problem. So that's where we come in. So for each of these questions, what I would like for you to start with, so put number 2, I first want you to tell me the units of capital P. So it gave you the units of what? Of lowercase p, right? What were the units of lowercase p? Potatoes per minute? Or which one? Per minute? Okay, so capital P, the units would be potatoes. So go ahead and write that. Yes, right? Just give me the units of the antiderivative first, and that's going to really help us, okay? So we want to first give that value, right? And Desmos got that, if we go to 3 decimal places, 150.402. And again, what are the units here you just told me? Potatoes, right? This is the antiderivative. It's the integral. You buy that? You're taking potatoes per minute here times minutes here. Okay. All right. So explain to me what this means. The integral answers the question what? How much? So what do we just find? Exactly. So we put 150.402 potatoes in the, was it a truck? Trunk? From t equals 0 to t equals 5 minutes, right? Make sure that you've got 2 units, one for your answer, one for your time. We are quick little potato throwers. All right, the next question said find p of 5, okay? Well, p, even though it's a function given, is really the derivative of capital P. Do you agree with that? It's a rate function, okay? So p of 5, we got that to be 25.867. And what are the units here? Exactly. This was the function given, but it's a rate function, right? So I can use my template from here. So we're going to say at what time? That's right, t equals 5 minutes. And what did capital P give me? Potatoes, so the number of potatoes is what? Increasing. Why? Because your rate is positive. Remember, little p is a rate function. Is increasing at a rate of 25.867 potatoes per minute. How many times do you see the word rate here? And what is how many units of time do you have in the denominator? Just the one, right? Okay. All right, and the last one was p prime of 5, right? So for p prime of 5, Desmos gave me 263.794. What would the units be for p prime, the derivative of p? Good. Potatoes per minute, or potatoes per minute squared. So this is the rate function of little p. Do you agree with that? This is the derivative of little p. So I can use that template one more time, right? I just need to, when I state the function, keep in mind that this is the rate of the rate. It's the second derivative, essentially, even though I just see one tick mark, because little p was already a derivative. You with me? Let's try it. It's going to start the same at t equals 5 minutes. And now I need to state what little p gave me, which was little p was the rate at which we put potatoes in the trunk, right? Is what? increasing. At a rate of, and the absolute value of that is itself. How many times do you see the word rate? Very good. How many units of time in the denominator? Always double check.